Let's solve some logarithms. Okay, I'm going to give you a couple different types to solve. The first one being the easiest. If you have a log equal to 1 log of the same base, the logarithms basically cancel out. Not really canceling, but we can make the answer or the argument equal to each other. So I'm just going to, the first one, this is super easy. I'm just going to say 10 minus 4x equals 10 minus 3x. Okay, now I'm going to take the 10 over to this side, so I'm going to subtract 10 here. So minus 10. Actually, now I have negative 4x equals negative 3x. So now I'm going to add 3x to both sides. And that's going to leave me with 0 on this side. And negative x equals 0, well, x is still 0 if you divide by a negative. So the first one, the answer is just x equals 0. Okay, so you set the two answers or arguments equal to each other because it's the log of the same base. There's nothing else in this problem. Moving on. Next one. We're going to take this logarithm, and we're going to need to convert to exponential. When you just have a log and then you have a number, you need to convert to exponential form in order to solve it. Now, before we do that, we need to get rid of this negative 6 in front. There's a couple ways you could do that, but the easiest way is to just divide by negative 6. So when I do that, it's going to cancel out right here. Okay, then I'm going to have log base 3 of x minus 3. Oops, let's fix that. Log base 3 of x minus 3 equals negative 24 over negative 6 is just 4. And now I'm going to take this and convert it to exponential. Now, how you do that is you take the 3 becomes the base. This is going to go up to the exponent. And now that's going to be equal to just x minus 3 on this side, 3 to the 4th power here. Now, 3 to the 4th, maybe you know it by memory if you've been practicing this, but if not, it's 81. We're going to add 3 to both sides, and we get our answer that x equals 84. And this one is now done. You always need to check that it doesn't give you a negative inside, but it doesn't, so you're done. Okay, so as long as you have a positive when you input x back into the original equation, it's not an extraneous solution. Same thing here. It leaves log of 10 equal to log of 10, so you're good. Okay, moving along. So now we're going to do ones that are a little bit trickier because we got to use one of those condensing properties. So now notice we have logs of all the same base. Okay, so the first thing we're going to do is we're going to rewrite this left side as log base 9 of, so that's a 9 there. Let's fix that. So log base 9 of x plus 6 minus means we're going to divide. So we're going to have x plus 6 divided by x. Okay, now we have the thing we had in the first problem that we have log base 9 of something equal to log base 9 of something else. So we can get rid of the logarithms and just set the two answers equal to each other. So that means we're going to multiply by x on both sides to cancel out this. So now this is going to cancel because we're multiplying by x on both sides. And then we're going to have x plus 6 equals 2x. I'm just going to move the x over this time. Usually I would do it the other way, but that means that 6 equals x, or as I like to write it, x equals 6. Okay, you can go ahead and check that it doesn't give you a negative, but it doesn't, so you're done with this one. Last one. Okay, we have a plus sign here, so what does that mean? Well, that means we're going to have to multiply to combine it into 1. So we're going to take log base 5 of 6 times 2x squared equals log base 5 of 48. Well, once I'm multiplying this, that means that I can take this and say that's really 12x squared equals log base 5 of 48. Well, notice here we got two logs of the same base equal to each other, so that just means that 12x squared equals 48. Well, now let's divide by 12. So I'm going to divide by 12, and that is going to leave me with x squared equal to 4. And now remember, when you take the square root, you're really getting two answers. You're getting x equals plus 2 and x equals negative 2. Now the reason I write this as two of them is because you always want to test both numbers to make sure it doesn't give you a negative. Now in this case it doesn't for either one, because when you square negative 2 you still get a positive number. And this one leaves me with a positive number as well, so I'm done with this problem.